word problems. So yesterday we were doing word problems with logs and stuff like that. Today we're going to do more of them. And we're going to mix in some regressions. So if you remember from last unit, we did sinusoidal regressions and quadratic regressions and cubic regressions. Now we're going to do exponential regressions. And we're going to do logarithmic regressions. So we're going to start off with this question right here. It says the population of Manitoba in 10,000s is given below. Here's the information. Create an exponential function to model this down. Anytime you're given data and told to make an equation, that means you've got to do a regression. So a review on how to do a regression, in case you forget. You're going to go second step, so that it brings you to your, you're just going to hit step. My bad. You hit step, and you're going to click the first option, which is edit, and that'll bring you to your two lists that you want to completely clear out. So if you go to the top list, you click clear, enter, and then top of the list, clear, enter, it should work.
That's second plus 4.
Oh, that's nice. That's pretty cool. There you go. So if you're in your list edit, you're going to make list 1 your x values, which will be your years, and list 2 will be your y values, your population. Remember how we do our years. The very first year is year 0. And then every year up from that, you just count. So 1961 would be 10 years after 1951. 1971 would be 20 years, then 30, then 40, then 50, then 60. If you had said that this was year 1 instead of year 0, then you would have had to do 11 and 21 and 31. That's why we always start with 0 as our year. So I'm going to go 0, 10, 20, 30, 40, 50, 60. In Y2, or list 2, I'm going to put all these populations. So I'm going to go 776.5, 921.7, 998.9, sounds like a radio station, 1035.5, 1109.6, 1159.4, 1250.6. And I'm going to double check my lists. So I'm going to make sure I didn't screw any of them up. And remember, like, having one number off can make your whole equation useless. That's why it's important that we double check. Double checking, everything's good to go. The next thing I need to do is my regression. So in your calculator, to do regressions, you go stat, and you click the right arrow 1 over, so that you're under the menu called calc. And you'll see there, you'll see some regressions. You'll see lin reg, quad reg, cubic reg, quart reg. You need to scroll down until you see exponential regression. You scroll down, it should be your 0 option, exp reg. exp reg, that means exponential regression. I'm going to click enter on that. It's going to bring me to that menu where it's like, X list, Y list, store, blah, blah, blah. I'm just going to hit calculate. And what it does is it brings up a screen that says Y equals A times B to X. And it tells you what A equals. It's 828.2. And tells you what B equals, which is 1.007. And it goes 0, 0. Around the 10 years, hundredth for both. So that's going to be 828.17 and 1.0, around 10 years, 100. What they've done is they've given you the formula for your exponential equations, and then they've given you the numbers that go in your formula. So your actual equation that would create this, y equals 828.17 times 1.01 to the power of x. That would be my equation that represents this function. If you got a different equation, you probably put a different number into one of your things. So maybe go back and double check your list if you made a mistake. So if there's that many people who got 828.49, it's probably me. So 828.40. Now I'm curious where I made my mistake. 776.5. 920. Yep, I put 920.7. It's 921.7. So you can see how one digit threw off my answer. That's all it was, one digit. And I even double checked and I didn't catch that. Alright. Estimate the population in 2020. So, 2020 means they gave you a year. Now, what year would that be in our equation? Yep. So 2021 would be year 70. You want 2020. So that would be year 69. You have two ways to solve this. Way number one, put 69 into your equation for x and just calculate it. Way number two would be to graph that equation and make x equal 69. In our case, I think at this point, it's easier just to plug that right into your formula and calculate it. So I'm going to go 828.17 times 1.01 to the power of 69, close the bracket, hit enter, and I get 1,635.486. So all I did was I put 69 into my equation and calculated my calculator. I wrote that in the wrong spot. I took the year that they gave me, and I put it into my formula for x. And then I calculated that. Yep. So if you graphed it, you would just have to go trace 69, enter, and it would tell you. It might come up with domain error. If it comes up with domain errors because your calculator can't see where the year is 1969 or 2008. Yeah, Jane.
Can we put it into our calculator?
Yeah, for sure. All right, so to put it in our calculator, I went 828.17 bracket 1.01 to the power of 69, close the bracket. Like that. My answer was slightly wrong because I never fixed my formula after I fixed my 0.17 to 0.49. So it is going to be slightly different. This should be 0.49. Okay. So if we do it with that number, it was 1646. Is that what you did?
Yeah.
Can you read off the first couple of decimals?
1, 2, 2, 1.
Thank you. Okay, what you get is put in your calculator graphing it there, kind of. Oh, not even close. Did anybody graph it get something close to that?
I
got that first.
8.49
0.49 when you're regressing it? I'll check that in a second. Who else graphed it? You graphed it? What'd you get, Gabe? For the year when you put 69, x equals 69.
I didn't graph it, I just put them
I
Yeah, I'm wondering
graphed
who
it, and then I
graphed it.
put like second trace value,
Yes.
and I put 69 in there, and then it got me 13.
Not even close.
Yeah.
Okay. The issue is a rounding thing, so that's a good lesson for Mr. Kennedy. It's the rounding of the 1.01. Right? So if you think about it, that makes a lot of sense. This is saying I'm growing at 1%, but I should have been growing at 0.7%. So to change from 0.7% to 1% for 69 years, that's a lot of change in your percentage. So that's why you're getting such drastically different answers. So with that lesson being learned, what we need to do is make sure you don't round. So if you use the bars trick in your calculator, that's the way to do it if you're graphing it. If you're doing it by hand, that means you need to write out all these digits. If you're creating an equation, it's okay to round for the equation, but then when you're solving for the answer, don't round anything. Okay.
What is your answer for C?
I haven't done C. I haven't done C.
So what's the right answer? The 13?
The right answer is, so what we would do is we would graph that. We would go trace 69, and the answer would have been the 1349. That doesn't make much sense either. So if you're thinking about the population of Manitoba, the population of Manitoba is definitely not 1,349 people. And that's also not what my answer is saying it is. What is my answer for population? Read that question and see if you can figure out what the answer is.
50.
The key word in there.
Yes.
In thousands. So that means you need to add 3 zeros to that thing. You need to move the decimal place 3 spots to the right. So the correct answer is 1,349,525 people. You have to move the decimals over to get the actual value. Right? It's important to know what they're measuring in. Question C. When will the population reach 1.5 million? That's when you need to go 1.5 equals, and then that formula we did. And in your calculator, you shouldn't have it rounded. Leave it 007 this time. This one's Y1. This one's Y2. 1.5 million is not going to be 1.5. What's it going to be? If I graph 1.5, that's not going to work. 15 closer. 1,500 would be the right thing. The reason why is I want to go 1, 5, 0 like that, and change it into thousands. So I need to move the decimal place 3 to the left this time to make it so that it makes sense with my graph. If I graph 1.5, that wouldn't work. If I graphed 1,500,000, that wouldn't work. Because your scale is in thousands. So I need to do 1,500 as my Y1 or my Y2, whichever you want to do. That should draw a straight horizontal line. You go second trace intersect. If you don't get an answer, it's because your calculator can't see where they intersect each other. So you might need to change your window so that it's big enough to see what's going on. Like for instance, my X maximum is at 100 and I can actually see what's happening. If your X maximum was at like 70, you wouldn't have been able to see where they crossed each other. So second trace max wouldn't have worked. So second trace max, enter, 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 and I get that, sorry, second trace intersect, I think I said max. Second trace intersect, enter, would be the 84th year. So you need to add 84 to 1951. 1951? Plus 84. 35, click. That would be the year that you had 1.5 billion people in Manitoba. This stuff's exactly like the sinusoidal graphs. Exactly like the quadratic graphs. It's just now you're doing exponents. And the next example you're doing logarithms. So, using the data below, create a logarithmic equation. What is the value of y when x equals 14? What's the value of x when y equals 15? I want you to try all three on your own. So give it a shot. Don't round when you're calculating for b and c. So to get your logarithmic equation, your calculator can only do logs if it's base e. So that means the natural log is the only thing it can regress. So you have to choose the option that is number 9, which is lin reg. That means logarithmic regression. It's just going to be the natural log, right? Ln. And when it does that, the formula it's going to give you, you have to read. The formula it gives you is y equals a plus b when x. Alright, so if you did your linear regression, if you did your logarithmic regression, you should have got an equation that was like close to 0.54 plus 3.11, natural log of x. Remember, natural log is just log base e. Right? We write it ln because it's just shorter. To figure out the value of y when x equals 14, I graphed it, and then I went trace 14, enter. Yep. My windows, that's a good question. So my windows for the first part of the question were 0, frozen. 0 is my minimum, and then 15 is my maximum for my x's. For my y's, I did the same thing. I started off as that as my window to start. The reason I chose those numbers is I looked at my information and I was like, oh, okay, like it's all relatively small. Then, for my third part of the question, when I went to do my window, I had to make my window way bigger on my x values. My y values, I only had 0 to 20. Because if you look, like 15 is not that big, so I need to be able to see 15, so I went to 20, so I could easily see it. But my x value, I noticed by graphing it, I wasn't even close to them touching each other. So I had to make my x maximum 200 before I could actually see where they cross each other nicely. So I changed my x min to maximum to 200, then I could see where they were crossing each other. Then I went second trace, intersect, enter, and they told me that the x value would be 104.4. But the windows are definitely the tricky part to these questions. Now, and if you did it without having a window where you can see the intersect, it just says like no change or something like that. Error, no change. Alright. We have 2 questions left. These are word problems that involve exponents or logs, and these are why logs are actually useful stuff. Because they actually are useful, which can sometimes be hard to imagine. We have the simplified formulas for why they work, but these are why they work. This is an old diploma question. So this question came off of a diploma 3 years ago, I think. So in 2010, an earthquake hit Haiti and measured a 7.0 on the Richter scale. It's Katie's job. In 2004, Indonesia was hit by one that measured 9.1. In order to compare their intensities, of those 2 earthquakes, the following formula may be used, where M and N are the Richter scale values of each earthquake. So if you want to compare like how many times something is to something else, so if I want to be like, how much times more money do I have than McGregor? I would take my money divided by McGregor's money. And if I had $10, McGregor had $5, I would have 2 times the amount of money he had, because 10 divided by 5 is 2. Right? So that's the same idea, except you can't just divide 9.1 by 7.0, because the Richter scale is actually working off logs. So the Richter scale is just an easy way to compare it, but it doesn't allow you to check how many times more it was in something. 9.1 is not the measurement of how intense that earthquake was. It's just a way for us to reference where it would be on a grand scale of things. That's all it means. The way to check their intensities is to use this formula. So the question that was on the diploma would be, how many times stronger was the Indonesian earthquake than the one in Haiti? So if you want to know how many times stronger it was, you needed to put the Indonesian Richter scale in for M, and the Haiti Richter scale in for N. So you had I equals 10 to the power of M, which would be 9.1, divided by 10 to the power of 7.0. You could actually calculate it. That's one way to do it. Another way to do it would be to use your exponent laws. If you have an exponent divided by another exponent, then it would just be 10 to the power of 2.1. You subtract the exponents. To actually calculate that, you go 10 to the power of 2.1, and it tells you that they were 125.9 times stronger than the other one. So the difference between a 9.1 and a 7.0 earthquake is 125 times more powerful. So it's quite a bit more powerful, I would say. I don't know what the highest on the Richter scale is. I think it probably goes off into infinite or something like that. I don't know.
So it's like 36, like actual like splitting of the line.
I don't know. Yeah, like 9.1 would be pretty good. Okay, do you remember what your family did for the highest possible? You're like, oh yeah, we chose Aunt Nona's birthday, so 25th was the highest.
I choose call.
When you put like the values in for M and N,
Yeah.
which ones?
Don't know.
How do you
I would
know?
never use call for that.
Good question. So, if you want to know how much times stronger something was, then the bigger value has to go on the top. If you wanted to find out how many times weaker something was, like how much less it was, then the smaller number would have gone on the top. It's always going to ask you stronger. So the bigger number goes on the top. Like if I was to say, how much more money, how much times more money do I have than McGregor, and I had $2 and he had $5, that question doesn't make sense, right? 2 divided by 5 wouldn't be times more, it would be less than, so it wouldn't work out.
Wait, so
The bigger number goes on the top.
you just figure out the thing you're multiplying it by just by doing simple minus of it.
Yep. And you could have just calculated it. So if it was multiple choice, 10 to the power 2.1 might have been the answer. If it was numeric response, then it would probably want 126, is my guess. They'd probably round it to the nearest whole number. But it would tell you, right, depending on the question. This was numeric response. The answer was 126. If it said round it to the nearest whole number.
I was like, you're wrong.
Yeah.
Right.
All right, this. Another diploma question. So this is where they used logs or exponents again. So this says a light source with intensity I naught. So when you have a little subset 0, that means I naught. Is reduced to an intensity I after passing through X meters of fog according to this formula they gave it to you. So they're saying light loses power as it's trying to come through something, which makes sense, right? If I'm shining a light through fog, the more fog it has to go through, the less light you're going to see. Makes sense. At what distance to the nearest tenth of a meter will the intensity be reduced to 1/2 of its original intensity? So that's a difficult question. I'm just writing out some info. I naught equals original intensity. I equals new intensity after it goes to the fog. There we go. X equals not the fog. What does E equal? The number. Perfect. E is not a variable in this question. E is the number E. Remember Euler's number.
So it's not Euler's number in this equation?
It is. Yes, it is. It'll always be Euler's number if you see E. If they give you E and make that a variable, they're human beings. E means Euler's number. All right, the question is, at what distance, so you're looking for X, will the intensity be reduced to 1/2 of its original intensity? They're asking, when will I equal 1/2 of the original intensity? Correct?
Correct.
So that means I could substitute this into this. I'm going to do that substitution. I'm going to show you a trick that makes it easier. So, I naught over 2 equals I naught, and then e to the power of negative 0.15x. I could simplify that equation by moving the I naughts to the same side. So divide by I naught, divide by I naught. And they'll cancel out on the right side. What will they also do on the left side? They'll also cancel out, leaving you with 1/2 equals e to the power of negative 0.15x. And thus, our trick. So, if you have a question that asks you to do 1/2 of its original, you can just make I equal 1/2, because the I naughts will cancel out if you were to do it properly and isolate them. So I could jump straight to the step of I naught equals e to the power of that, and I can get rid of the original intensity. Because I know I just want to be half of it. That's what my goal is to get to 50%. So 1/2 equals e to the power of negative 0.15x. The same way it is with any equation. If you have something on one side of the equal sign and something on the other, I can graph it. That's y1, that's y2, and I can find where they cross each other. I just want you to know you can do that for anything. Like if I had some huge quadratic equals some other huge quadratic, I could just graph y1, y2, and find where they cross each other, and it would work. If I had something crazy like 10 over 6 to the power of 2x plus 5 equals 200 divided by 16 to the power of 5x, I can just graph y1, y2, find where they cross each other. So that works for everything. The only time it doesn't work is if you have multiple variables, right? So if I had like x's and y's in here, then that doesn't work. But this trick of like make this equal this, y1, y2, it works for everything. So I've been using it a lot recently because these are really hard to calculate otherwise. But you could do it for really simple questions, and it would still work. Hey.
Is E just the little leader on the...
E is the number E.
On the
Yeah.
efficiency?
Yes. So if you wanted to figure this out, you need to graph 1/2 into your y1, and then e to the power of negative 0.15x into y2. E to the power of negative 0.15x. My window is going to be kind of tricky. Think about the question. X is the amount of fog that you're going through. The least amount of fog I can go through is 0 fog. The most meters of fog I could see through, I have no idea. I've never really tested fog depths before. So I'm going to guess like 100 meters would be a lot of fog to be looking through. So I'm going to say 100 meters is my X maximum. What I do know is easy to calculate is my Y max and my Y min, because Y1 equals 1/2. So I don't want a very big Y maximum. And I don't need a Y minimum that's any lower than 0. So I need 0 as my Y min and 1 is my Y max. 1 as my Y max. And when I graph that, I get a graph that looks like this. So that was with my X from 0 to 100, and my Y from 0 to 1. That's the graph I come up with. It looks, I made the red a little bit bigger than it actually is my graph. It's a little tighter to the Y-axis. The two biggest mistakes that you guys are making is how you're putting them in your calculator. So, some people have this. You have a line like this, and a line like that. If you have that as a graph, where you have two horizontal lines, there's a whole bunch of you who have that, in your calculator, you forgot to put x in as your exponent.
Oh,
You did e to the power of
Oh,
negative 0.15, and you forgot to put x.
Yeah.
You didn't get this graph. The second mistake that people were getting was if your graph looked like this. Where you had a straight angle like that, and then you had a horizontal one like that. And that's the one that's happening the most often. Okay, what you guys are doing is in your y2, so go to your y equals, you have e hat negative 0.15 x, correct?
Yep.
Your calculator reads this as e to the power of negative 0.15 times x. So what you need to do is put brackets around that. And then you would be telling your calculator it's negative 0.15x as the whole exponent. If you don't put brackets, it thinks that x is by itself. It thinks the exponent was just negative 0.15. So those are the two errors I saw going around the room. Other people had some window errors, but they were adjustable and fixed. If you had something else and you just were too afraid to tell me, then you can. But those are two common mistakes we had. If you fix that, you should get a graph like this. And then you go second trace intersect, figure out where they cross each other. So second trace intersect, enter, enter, enter. They cross each other at 4.6. So the amount of fog you would have to go through for it to be half its intensity would be 4.6 meters of fog. Anybody have any questions? That Y1, Y2 trick can bail you out of a bunch of questions on your diploma. So it's you kind of have to use it for this unit, but you could use it in other units. Like that rationals unit that we did, you definitely use it for that. So remember when we were solving those crazy equations? Sometimes you can just graph a Y1, Y2. Not often, and then they're getting better on the diploma of making sure you can't do that. But sometimes it's still possible.